Tracking comets accurately has always been one of the more demanding challenges in astronomy, not because these objects are rare, but because they are dynamic, unpredictable, and often faint visitors that move against a constantly shifting cosmic background. This difficulty becomes even more pronounced when the object in question originates beyond our solar system, carrying with it an unfamiliar trajectory and physical behavior shaped by conditions astronomers may never directly observe. The interstellar comet known as 3I/Atlas represents precisely such a challenge, and its arrival has prompted a coordinated international effort involving United Nations bodies, NASA scientists, professional observatories, and citizen astronomers. As 3I/Atlas moves toward its closest approach to Earth on December 19th, coming within approximately 167 million miles, or about 270 million kilometers, the campaign to track it has become a proving ground for the future of planetary defense, precision astrometry, and interstellar science. Unlike periodic comets that return on predictable schedules, interstellar comets like 3I/Atlas enter the solar system only once, following hyperbolic paths that indicate they are not gravitationally bound to the Sun. This makes early and accurate tracking essential, because the observational window is limited. Any uncertainty in the comet's position compounds rapidly over time, complicating predictions of its future motion and limiting opportunities for detailed study. Recognizing this, astronomers have mobilized a global network of telescopes to refine measurements of 3I/Atlas's position with unprecedented accuracy. These measurements, known as astrometry, involve determining the precise coordinates of an object in the sky relative to background stars, often down to fractions of an arcsecond. Even slight improvements in this precision can significantly improve orbital models, allowing scientists to reconstruct where the object came from and where it is headed next. A central role in this effort is being played by the International Asteroid Warning Network, or International Asteroid Warning Network, a United Nations endorsed collaboration that brings together more than 80 observatories and research groups worldwide. Although its name emphasizes asteroids, the network also focuses on comets and other near-Earth objects that could pose scientific or, in rare cases, impact-related concerns. Coordinated by NASA, the network was established to improve global readiness for detecting, tracking, and characterizing objects that pass close to Earth. Since beginning its observing campaigns in 2017, IAWN has conducted several large-scale efforts to refine tracking techniques. But 3I/Atlas marks the first time the network has applied its full campaign framework to an interstellar object. The significance of this cannot be overstated. Interstellar objects provide a direct sample of material formed around other stars, offering insights into planetary systems far beyond our own. Yet, because such objects move quickly and unpredictably through the inner solar system, they test the limits of existing observational infrastructure. According to James Bauer, a principal investigator with IAWN and a research professor at the University of Maryland, the 3I/Atlas campaign is as much about improving technique as it is about studying the comet itself. By coordinating observations across many sites, astronomers can reduce systematic errors, cross-check measurements, and experiment with new methods of data reduction and analysis. This collaborative approach ensures that no single observatory bears the full burden of tracking such a fast-moving and distant target. One of the primary goals of the campaign is to test a new astrometry technique designed to improve the accuracy of sky position measurements for faint, diffuse objects like comets. Traditional astrometry works best for point-like sources, such as stars or compact asteroids. Comets, however, often have extended comae and tails that make it difficult to determine their exact center. Small differences in how different observers define this center can lead to discrepancies in reported positions. By standardizing methods and applying advanced algorithms, the IAWN team hopes to produce a cleaner, more consistent dataset for 3I/Atlas. If successful, this technique could become a new standard for future observations, benefiting not only planetary defense, but also mission planning for spacecraft encounters. The practical implications of such improvements extend far beyond academic curiosity. Precise tracking is essential for any future attempt to intercept or rendezvous with an interstellar object. While no mission to 3I/Atlas is currently planned, the knowledge gained from this campaign could inform the design of rapid response missions in the future. Such missions would require extremely accurate predictions of an object's path to calculate feasible trajectories within tight time constraints. Even a small reduction in positional uncertainty could make the difference between a mission being possible or impractical. The timing of 3I/Atlas's arrival has also been remarkably fortunate. IAWN had been planning an observing campaign since October 2024, anticipating the need to test and refine its capabilities. When 3I/Atlas was discovered in late June, it fit almost perfectly into this schedule. Its brightness and visibility from many of the network's observatories made it an ideal target, allowing for sustained monitoring over several months. This alignment between planning and opportunity highlights the importance of maintaining readiness in planetary defense networks, as rare events often arrive with little warning. NASA's role in coordinating the campaign underscores the agency's broader commitment to near-Earth object research and planetary defense. Through programs like the Planetary Data System Small Bodies Node, which Bauer also helps oversee, NASA ensures that data collected from campaigns like this are archived, cataloged, and made accessible to researchers worldwide. This openness not only accelerates scientific discovery, but also fosters international trust and collaboration, a crucial element when dealing with phenomena that transcend national boundaries. The 3I/Atlas campaign also builds on lessons learned from previous IAWN efforts, including observations of the near-Earth asteroid Apophis in 2020 and 2021. Although Apophis poses no threat during its upcoming close approach in the late 2020s, it provided a valuable test case for coordinated tracking and communication. The experience gained during those observations has informed the strategies now being applied to 3I/Atlas, from data-sharing protocols to methods for engaging amateur astronomers. Citizen scientists play a meaningful role in these campaigns, often contributing observations from regions not covered by major observatories and helping to fill gaps in temporal coverage. As the campaign progresses, the data collected will be analyzed and eventually published in a peer-reviewed journal, providing a detailed account of both the comet's behavior and the performance of the new tracking techniques. This publication will serve as a reference for future campaigns, offering a benchmark against which improvements can be measured. It will also contribute to a growing body of knowledge about interstellar objects, a field that has expanded rapidly since the first confirmed detection of such an object only a few years ago. Beyond the technical achievements, the campaign surrounding 3I/Atlas carries symbolic weight. It demonstrates how international cooperation, guided by scientific curiosity and shared responsibility, can address challenges that no single nation could tackle alone. The involvement of the United Nations through IAWN emphasizes that planetary defense and space science are global concerns, requiring coordination, transparency, and mutual support. In an era where space activity is becoming increasingly crowded and complex, such cooperative frameworks will be essential for ensuring both scientific progress and planetary safety. As December 19th approaches and 3I/Atlas reaches its closest point to Earth, astronomers will continue to refine their measurements, reducing uncertainties and testing the limits of current technology. Once the comet departs the inner solar system, it will likely never be seen again, continuing its long journey through interstellar space. Yet the legacy of its brief visit will endure, embedded in improved techniques, strengthened networks, and a deeper understanding of our place within a galaxy filled with wandering worlds. Through efforts like this, humanity moves closer to being not just observers of the cosmos, but active participants in understanding and safeguarding our celestial neighborhood.